The last class we have started with the Turing machine, isn't it? So here the main difference between PDA and Turing machine is in the case of PDA we'll be using a stack, right? Whereas in the case of Turing machines, here we'll be having an infinite length tape. Okay, so we'll be having an infinite length tape where it is open-ended. Okay, so here the tape head can move towards the left and towards the right direction. Okay, so here this is how the elements will be filled inside. So here, please make a note over here. This B, capital B, is represented for blank symbol. But if you refer books, each and every book will follow different conventions. So only thing is that blank symbol should not be used in the input or any other particular symbols. Okay. So here, some of the books will use this symbol as blank. So this is a special character. Okay. So only for representing the blank space, it is going to be used. Okay, so here we can start with a simple example and then move on to the, actually we started with A parent, B parent, C parent, which is a bit complex. Okay, so first we can start with a very simpler one and then we can move on. Okay, so what are the operations that can be performed in this team? Here, please make a note. This is my let us consider this is the initial configuration. Okay, so this is my input symbol and the rest of the places are filled with blank. Okay, blank. So what are the operations that are performed on the particular tape? So this is my, yes ma'am?
Like we can move left or right.
Yes. So yes, as you say, I can move towards the left or right. So here in the tape head, this is my tape head, right? So this tape head, so whichever it is pointing to, okay, so I can read and scan the symbol that is pointed out by this tape head. Okay, so this symbol I can read and scan. And then what I can do, I can update and write a symbol. So update or write, that is read operation I can perform, and then I can perform write operation. So instead of this, whichever position my tape head is pointing to, in that spot I can perform read operation, I can perform write in the sense update operation, and then as you say I can move my tape head towards the left or towards the right. So this is the operation that can be performed on the tape. Okay, so it can read the current symbol, it can read the current cell space. Okay, it can update the current cell space, and then it can move exactly one cell towards the left or one cell towards the right. Please make a note over here. At a stretch I cannot move towards this particular point. At one point of time, by watching at one point of time I can move, this tape head can move from one cell to the another cell. That is, only one cell movement is possible towards the left direction or right direction. Okay, how I am going to represent my Turing machine? So here, okay, so this is one state and this is another state and this is my transition. So how I am going to represent the transitions here? Okay, so here this symbol, okay, so this is the symbol to be read. I am in state, let me call this a state QI and this is QG. Okay, I am in state QI. In QI I am reading, that is my tape head is pointing towards this position. Okay, this symbol represents the symbol that is read. Okay, symbol to read, and this is symbol to write. Okay, so this symbol is going to be updated by this symbol, and then I'm going to move my tape here towards the right. So just convention I am saying how we are going to represent the Turing machine, that is what we are dealing here. It will be clear for you when we deal with the example. Okay, so this is the symbol that is read by the that is pointed out by the tape head, and this is the symbol that is going to be updated. Let us consider the scenario where I want to update the cell as B. In that case, for example, if my tape head is reading A, then I should update it by B, and then I have to move my tape head towards the right side. In that case, I will be represented by this fashion. Okay, so here this read, in the sense, as you see, in this case it is going to be moved towards the right side. If I am going to move towards the left side, then it is going to be represented by L. If suppose, so here in this case I am performing some updation in the cell. If suppose I am not going to perform any updation at all, then how I am going to represent it? So same thing, Qi, Qj. So no, just reading, I'm not going to update anything. So in that case, same symbol is going to be placed over here. Okay, A, update nothing, just move the tape head towards the left side. Okay, so this is how we are going to represent the Turing machine. This is how we are going to construct the Turing machine. Already we have seen the tuples, right? Now we can start with a very simple example. That is 0, 1 star 0. What do you infer from this expression? Actually, this is a regular expression. You can even use a finite automata to check this pattern. Just we are going to see the functionality of Turing machine. That's it. Very simple example we have taken, and we are going to construct the Turing machine for this. Okay. What do you infer from this language?
It starts and ends with 0 and can have any number of ones in between.
Yes. So start with 0 and end with 0. As you say, in between I can have any number of ones. Okay. So here, this is my tape head. Okay. So let us consider my string is this one. This is a valid string. I want to construct a Turing machine to check whether this particular string belongs to this language or not. Okay. So here, 0, 1, 1, 0. The rest of the places is going to be filled with blank. Okay. What I am going to do is, so here what should I do? It should start with 0 and it should end with 0. Intermediate I can have any number of ones. I cannot have any zeros. Okay. So in between I cannot have any zeros. Right. So I have to differentiate between 0 and 1. Okay, so what I'm going to, first let me tell you the logic and then we can move on with the design of the Turing machine. So what we are going to do now is, so this is my initial configuration, this is my tape head position. So what I'll do is, I'm going to, if I visit a 0, then I'm going to replace it by X. Okay, if I visit a 0, then I'm going to replace it by X. Okay. If I visit a 1, then I am going to replace it by y. Okay. So, 0 by x and 1 by y. Okay. So, here you can see, here in this case, my Turing head is my tape head is scanning 0. So, it should be replaced by x. So, this is replaced by x and then my tape head is moved towards the right side. Now, this is y. If this is y, what should I do? It should be replaced to.
Y.
So just to infer it is a visited slot, I am marking. That's it. Okay. It should be replaced to y. And next, tape head movement. So this is y. Sorry, this is 1. Replace to y. Move my tape head towards the right. This is 0. Change it to x. Move the tape head towards the right. Okay, now I am coming across a blank symbol. So what I will do, so here please make a note. If I am coming across a 0 over here, what I should do, I should not be able to reach the final state. If this is the sequence, whatever may be the number of ones comes in between, then I will be in a position to reach the final state. Okay, or else I should be moving on to the reject state. So considering this, I am going to actually, so please make a note over here. Just an example we are seeing, actually for this scenario, the Turing machine is not required. Okay, so this is this we can design a finite automata as well. Just for simplicity, we have chosen this one. Okay. Yes, Q naught. Yeah, I am in state Q naught. Blank represents end of the string. Okay, so here I am coming across 0. I am coming across 0. So what should I do? 0 should be changed to x, and then I have to move my tape head towards the right side. And then I have to move on to another state. Let me call that state as Q1. Okay. If suppose if I am coming across 1 here I am in state Q0. In Q0, if I see 0, I'll be changing this to x, and I have to move on to Q1. That is, I have to move my tape head towards the right. What happens if I come across a 1?
I'll stay on the same state and change it to y and move right.
Is it a valid string? In this slot, if 1 is present, is it a valid string?
No, ma'am.
No, it is not a valid string, right? I should move on to a reject state. Okay?
Reject state.
Yes. So 1, I need not do anything at all. Just move my tape head towards the right side and then move on to a reject state. Okay, just move on to a reject state. Okay, now I am here in this position. Okay, if 1 comes, I'll be in this position. If 0 comes, I'll be moving my tape head towards. After changing this to x, I'll be moving my tape head towards this position. Now I am in state Q1. In Q1, I am coming across 1. So what should I do?
Replace it with y and move the tape head
And
to right.
similarly, is there any restriction on number of ones here?
No, ma'am.
So I can be in the same state. Okay, whatever may be the number of ones comes, even though if there is no 1 at all, I need not worry with regard to that. Okay, so here 1, then replace by y, and then move the tape head towards the right side. Okay, move the tape head towards the right side. Yes, again the same thing. Let's change to y and move the tape head towards the right. So okay, in Q1 I am coming across 0. So what should I do?
Replace it with x.
Yes, and then move my tape head
Move
towards
towards
the
right.
right side, and then I'll be moving on to state Q2. So now this is changed to x and move my tape head towards the right. Now I am in Q2. Okay, in Q2 I am coming across a blank symbol. So what should I do? I should be reaching the
Final state.
final state. So because I have crossed the sequence, right? So 0, 1, 1, 0 is crossed. So I'll be moving on to the final state. Okay, so blank, do nothing, just move the tape head towards the right and then move on to Q3. Okay, so here let us consider this scenario. Yes, as you say, if 1 comes, I'll be moving on to reject state, right? So that's over. Let us consider I am having 0 here, and then I am having blank here. Is it a valid string? Or let us consider is it a valid string?
No, ma'am.
No. Do you all agree with that, ma'am? What about others?
Yes.
Yes. So this is changed to x. Now I am in state Q1. In Q1 I am coming across 1. So this is changed to y and then move the tape here towards the right. Again I am in state Q1. In Q1 I should either say 1 or 0. In this case I am coming across blank. As you say, it is not a valid string. So valid string, right? So what should I do? I have to move my tape here. Sorry, I have
To
to
reject state.
reject state. So blank, blank, do nothing. Okay, so moving on to reject state. Okay, so let us consider another scenario. Is it a valid string?
No, ma'am.
So here x, y, x. Now actually I am in
Q2
this
state
position.
also.
I am in state Q2. Okay, so in Q2 I am coming across 1. So is it a valid string?
No,
As you
ma'am.
say, it is not a valid string. So what should I do? I have to move on to
Reject
reject state. So 1, do nothing. Just move the tape head towards the right. Again, if it is 0, is it a valid string? 0, 1, 0, 0. Is it a
No,
valid
ma'am.
string? No. Again, it should be moving on to the reject state. Are you clear with this?
Yes, ma'am.
Yes. So again we can move on to the next very simple example. Okay. A power n, b power n, where n is greater than or equal to 1. Okay. So a power n, b power n. Yes, again as you are aware, it can be, we cannot, can you use a finite automata to check this language?
No, ma'am.
Can we construct? No. What about PDA?
Yes, ma'am.
Yes, we can construct a PDA. Now for simplicity, we are using this for constructing the Turing. Using the Turing machine, we are going to evaluate this expression. First, let me discuss you the logic, how we are, so please make a note over here. You will find different logic to solve a task. So here, for example, I am solving it in this particular logic, that's it. Okay, so please don't think that it is the only way possible. So you will be finding different possibilities. Okay. Yes. So the Turing machine, what we are going to construct now is going to follow this logic. That is what I'm going to discuss here. A, B, blank. Okay. So this is my string. So let us first see the logic behind, and for that logic we are going to design the histogram. So what is it? Turing machine. Okay. So here again, in order to designate, so first I should have sequence of A's and then I have to designate a sequence of B's. And here, as you all aware, I should have exact same number of equal number of A's and B's. So what I'm going to do is A's are if I visited input symbol A, then it is going to be marked by X, and if I visited input symbol B, then it is going to be marked by Y. Okay. Here, this is my tape head position. So what I'm going to do is, so first I'm visiting a A. So in order to inform that I have already visited it, and this is A, I'm going to replace it by X. And then I'm going to, so for each and every A, I'm going to mark a B. Okay, I'm going to equalize it with a B. Okay, considering that, I'm going to move my tape towards the right till I reach a blank symbol. Towards the right till I reach the blank symbol. So why I have to reach the blank symbol? The last B. So in order to find the last B, I have to move my tape towards the blank symbol. Only then I can move my tape to this point. Okay. So I'll be moving my tape towards this right, and then I'll be reaching this point. On reaching a blank symbol, I'll be moving my tape towards the left side and I'll be pointing over here. So this is going to be my last B. Okay. So here I'm going to change this B. Okay. Change this B to Y, and then I am going to move my tape towards the left till I reach X. Okay, because I have to mark visit the next A. So considering that, I am going to move my tape towards the left. So on visiting X, I'll be moving my tape towards the right. Okay, so now I have visited the next E. So what I'm going to do, I'm going to update it as X, and then I'm going to move my tape towards the right side. So till which point I have to move my tape towards the right side? Here again I have to
Till I reach Y.
Y. Yes, good. So in this case, I have to move my tape till I reach Y. Okay. So on reaching Y, I am going to move my tape towards the left side. Now this is my, at this stage, this is going to be the last week. Okay. So I'm going to replace it by Y, and then I'm going to move my tape towards the, what is it? Towards the left side. Okay, so towards the left side. So here, as seen previously, I'll be moving my tape till I visit X. On visiting X, what should I do? I have to move my tape towards the right side. So immediately on moving it to the right side, I am visiting Y. What is the meaning? When I will visit Y? This condition I will meet only when now there are equal number of A's and equal number of B's. Do you all agree with that?
Yes, ma'am.
Yes. So for this only we are going to, so this is the logic we are going to follow for designing this Turing machine. Okay. So let me repeat, you can go for any of the logic. So in this example we are using this logic, that's it. Right. Okay. So here I am in Q0. Okay, so here what we are going to do, so here this A, so this is my initial configuration, right? This is my initial configuration. So here what should I do? So I'm visiting a A, I am in state Q0. In Q0 I am coming across A, so what should I do? This A should be changed to X and then I have to move my taper towards the right side. So A should be changed to X and then move the taper towards the right side. Okay, right? Now I am in state Q1 until which position I have to move my tape head.
Just to move it to right blank.
Till I reach
Blank.
blank. Yes. So here if I, so as you say, what should I do? If I visit A, I should not do anything, just move the tape head towards the right. If I visit B, just move the tape head towards the right. I have to make a decision only if I visit blank. Okay. So till that point I'll be in the same state Q1. So A, move right. B, move right. You can be in the same state Q1. Okay. In Q1, if I visit B, okay, here I am in Q1. In Q1, I am visiting B. So what should I do? So this blank, I need not do anything. Just move the taper towards the left side. Just move the taper towards the left side. Now I am in this position. I am in state Q2. So I am in state Q2. So now I am in the last B. Okay. First A, last B. Okay. That is how we are going to mark it. So here, yes, I have visited the last B. So what should I do? I have to change that B to Y and then I have to move my taper towards the left side. So this left side movement until which point I have to move, perform? This is my current status of my taper. Okay, so now as you say here after changing this B to Y, I have to move my taper towards the left side. Okay, I am in state Q3. In Q3 I am in state Q3, so this leftmost movement till which point I have to proceed with? What is my target? X and Y, that is A and B mapped. Next target is to map these two. Next target is to map these two. Okay. So I have to read, that is I have to scan this input symbol. So in order to scan this input symbol, I have to move my tape head to a particular position. That is what, which position I am asking for. What happened, ma? Huh?
We will move to left till we reach an X.
Yes. So here please make a note. I want to scan this symbol. Okay. I have to scan in the sense I have to scan the symbol and then I have to compare with the next B. So considering that, in order to catch this symbol, I have to move till this point. Okay. Till I reach X, I have to perform the left movement. On reaching the symbol, what is the meaning? So I have reached the already visited alphabet. That is the meaning. Okay. So considering that, I can move my taper towards the right side. So what should I do? I have to proceed with the that is AA, move left, BB, move left. I can just move my tape here towards the left side, and I can be in the same state, that is Q3. Okay, like this I'll be moving on here. Now I am in this position. In Q3 I am coming across X. So what should I do? On reading X, I have to move my tape here towards the right side. Okay, so here that's what. So after this, what will be the sequence to be performed on? Where should be my transition? In Q3 I am coming across X. In X, what should I do? I have to change, I need not do anything to that particular cell. Instead I have to just move my tape towards the right side. After moving to the right side, what will be the sequence to be done? This A should be changed to X, and then I have to move my tape here towards the end of the, that is the last B. I have to track it off, and then I have to proceed with the same sequence, right? So already this sequence we have done. Where it is? From Q3, where should be my transition? On seeing X, where should be my transition? Is that clear? After on seeing X, I am in state Q3. I am in this position. Okay, I am in this state. In this state, I am seeing X. On seeing X, what will I do? I will not do anything. Just I will be moving my tape towards the right side. Okay, that is X, X, R. Okay, so after that, what will be the next sequence of steps? What should I do? I have to change this A to X, and then I have to traverse towards this direction. On seeing a Y, I have to move towards this position. This B should be changed to Y, and then I have to move towards this position. On seeing a X, I have to move towards the next point, and this A should be changed to X. Like that, the sequence goes on. That sequence, should I introduce in a new way, or is that already existing? Changing A to X, where you can see here. What happened now? Can you see here? So here, what is the sequence being done? So here I am in state Q3. In Q3 I am coming across X. So this X is changed. We need not change any, we need not make any updation to this cell. Just move the tape towards the right side. Okay. So after this I have to change this A to X. And then I have to move my tape here towards the right side. This particular operation where we are doing, in which state we are doing this? Is this operation already existing or not? What happened, ma'am? Am I
No, ma'am,
audible?
because the first bit was still blank.
That we can update, ma.
Yes,
Yes.
rest
Yes,
exists.
yes. Ah, yes. So here, what will I do is, I'll be having the transition from Q3 to Q0 for this one. X towards the right side. Okay, so now what should I do? This A, so I am in state Q0. In Q0 coming across A is already there. This A is changed to X, and then move the tape here towards the right. I am in state Q1. In Q1 I am coming across A. Just to do nothing, just move the tape here towards the right. Okay, just move the tape here towards the right. Like this I will be moving on till which point I have to move, till I reach, because my target is to find this B, locate this B. In order to locate this B, I have to traverse till the previously visited B, which is Y. Okay, so here I have to traverse till I visit Y. So what should I do? Till that point I have to proceed with. Okay, so here I have to include another transition, that's it. Okay, so here I have to include another transition, y, left. So here I have visited y. So I am going to move on towards the right side. Okay. Now I am in state Q2. In Q2 I am visiting B. So what should I do? It should be changed to Y and then move on towards the left side. So whatever may be the number of A's and B's, I have to move on towards the left side till I reach X. Yes, I have reached X. What should I do? I have to move my taper towards the right side. Yes, this is changed to, now I am in state Q0. So I am in state Q0. In Q0 I am coming across A. So this should be changed to X and then I have to move my taper towards the right till I reach Y. Okay, so I have reached Y here. On reaching Y, what should I do? I have to move my taper towards the right side. So I am in state Q2. I have reached B. So this is going to be replaced by Y and then moving my taper. Now I am in state Q3. Okay, in Q3, yes, this is Q3, right? After changing to Y, I will be moving my taper towards the left and this is Q3. Okay, so in Q3 I am coming across X. On coming across X, what should I do? If I see X, I have to move my taper towards the right side. Okay, so this is my current status. Okay, this is my current status. So in Q0 I am coming across Y. So what should I do now? What should I do? What is the meaning here? There are equal number of X and equal number of Y's, right? Only then I will be reaching this condition. So what should I do? I have to reach the final state. Okay, so I have to reach the final state. So Y, I can move my taper towards the left or right. The only thing is that I have to reach the final state, that is Q4. Is that clear? What happened?
Yes, ma'am.
Yes, it will be, you will be familiar. So you, initial stage, right? So when we see further examples, then it will be clear for you. Okay. Okay. Okay, next we are going to move on to the next level of example where we are going to perform a copy operation. As already discussed, with the help of Turing machine, you can perform. That is, here in this case, we are dealing with the accept. That is for a given string. We are checking the sequence whether it is following the particular language or not. Okay, so here we are going for accept as. The next is going to be the Turing machine. We can have transducers as well. Transducers in the sense we'll be dealing with some set of functionality. That is, we'll be dealing with some operations. You can perform, you can design an adder, you can design a subtractor, you can design a Turing machine to perform copy operation. Okay, can you all differentiate between here? So here in this case, what we are doing, we are checking whether the given string belongs to this pattern or not. That's it. Similarly, here this Turing machine, we are using to check whether it belongs to this given pattern or not. If it belongs to the given pattern, then we'll be moving to the accept state. Okay. Similarly, here accept state. So here the next is going to be performing a particular action, operation. Okay. So one such example is copy a string. Okay, I'm not going to check a pattern. Instead, I'm going to perform a specific operation. Okay, that is, consider this particular string 101. In order to mark the end of the string, we'll be having a marker. Let it be hash. Okay, the string is terminated by hash. The string is terminated by hash. What is my target is I have to make a copy of the given string. Okay, copy of a given string. So what should I do? If I visit a 1, then I have to, that is, this will be my initial configuration. Let us first discuss the logic and then we can move on with designing the Turing machine. So this is the initial configuration. This is the initial configuration. Here I am going to perform a copy operation. Copy in the sense, at the end my tape should have 101 hash 101. How we are going to perform? I have to, so if I see a 1 here, then I have to rewrite blank as 1. Okay, it should be updated as 1. If I see a 0 here, this blank should be updated as 0. Okay, so here please make a note, I can have any sequence, but my target is I have to replicate this. Okay, so here 1, if I see a 1, I'll be changing it to 1. If I see a 0, then I'll be changing this to 0. If I see a 1, then I'll be updating it to 1. So what we have to do is, I have to differentiate between 0, that is my Turing machine, when it reaches the blank symbol, it should be aware whether it has already visited 0 or it has visited 1. That is, if it has visited 1, then in that blank space it should place 1. It should make a copy of 1. If it has visited 0 and reached a blank spot, then it should replace it by 0. Okay. Considering that, it should be differentiating. Your Turing machine should take should keep it in memory on reaching B, that whether it has previously visited 1 or it has visited 0. So simple logic what we can see here is, so if I visit 1, so as usual, so let us consider 1 is 0 is designated by X and 1 is designated by Y. Okay, here in this case I am visiting 1. So in order to know that I have already visited this cell, let me make it as Y. Okay, and another thing, I should have both the copy of 101 and 101. So here till this point we were worried only we have equal number of A's and B's. We were not bothered after checking this, what is there in the tape at the end. Okay, so here you can see, after checking the sequence, I am having only 3x and 3y, and it is not having 3a's and 3b's. Okay, so whereas in this case I should have 101 hash 101 at the end. Okay, so that thing we have to put. So what I'm going to do is, this 1 is going to be changed to 0 and changed to y. Please make a note, my Turing machine should keep it in memory that it has visited 1. Okay, so and then I am going to move towards the right till I see a blank symbol. Okay, on reaching the blank symbol, as my Turing machine is aware it has reached this point after visiting 1, what it will do, it will update this as 1 and then it will move the tape towards the right side, towards the left side. Okay, if it has visited what is it, if it has on moving, so what it is coming across here, it is coming across y. Okay, if it is coming across y, what it will do is, actually what it do, it has to move the tape towards the right side. In addition to that, I have to update the cell to the previous value. Okay, already what we tell, so if it is 1, it is changed to 0. If it is 0, it is changed, it is marked as X. Okay, so here on seeing a Y, what my Turing machine will be aware of, instead of 1, I have replaced it by Y. That it is we are already aware of. So what it will do is, this Y is changed to 1 and then the tape head is moved towards the right side. So this is X0. So this is changed to X and move the tape head towards the right till I reach the blank symbol. On reaching the blank symbol, this should be changed to 0 and move the tape head towards the left till I reach X or Y. So here in this case I have reached X. If it is X, change it to 0 and then move the tape head towards the right side. Now here it is 1. So change it to Y and move the tape head till I reach blank symbol. Okay. Now this blank is going to be changed to 1 and then move the tape head towards the left till I reach X or Y. In this case this is Y. Okay. So this is changed to 1 again and then move the tape head towards the right side. So here I am coming across hash. So what is the meaning? Hash is the terminating symbol. Okay, end of the string representation. Okay, so my string is over. So when I reach this hash, my task will be over. The Turing machine has completed that task. So now what is there in my tape? 101 hash 101. Is that clear? Hmm? Okay. What we can do is, please do try it out on your own. Okay. It's almost 4:32, right? So please do try it out on your own. We can see the answer in the next class. Okay. Please do try. Please don't refer with any other materials. Try it out on your own, and you will have the confidence. If you have any other doubts, you can ask me. Are you clear with this?
Yes, ma'am.
Yes. Yes, I do agree. You will not have full confidence, so it will take some time for you. So only today we have started with it, right? By practicing some more examples.